Hi friends, how are you? So I think this is the last video which I am making on the questions that were asked on the subject EMF for the AP Polytechnic Lecturers examination conducted in 2020. I think this is the last video we will see. After that we will see the questions from circuit analysis, from control systems as well as from measurements. So we'll see one more question. So the question is like this: you have two charged sheets given. In the problem, there is given that two charged sheets are given. One charged sheet is having plus sigma coulomb per meter square area, and you have another sheet of minus sigma coulomb per meter square area, and these two are separated by a distance d. Now it is given that when two sheets are placed like this, separated by a distance d, at anywhere in between the sheets, what is the electric field intensity? So we know that this sigma is nothing but the surface charge density ρs, charge per unit area. Now for an infinite sheet, we know that the electric field intensity can be given by ρs by 2 epsilon naught an bar. For an infinite sheet, this is the expression for electric field intensity. Now, I am assuming that this sheet is at z is equal to 0 plane, and this sheet is at z is equal to d plane, as the separation is d. Now, at any point in between the plates or in between the sheets P, the total electric field intensity E suffix P bar can be taken as the summation of two electric field intensities. One electric field intensity is due to the first sheet at the point P, and another electric field intensity is due to the second sheet at point B. Okay? Now what is the electric field intensity at point P due to the first sheet? It is ρs by 2 epsilon naught. What is ρs? Sigma. So for the first sheet it is plus sigma. So sigma by 2 epsilon naught. An bar is nothing but a unit normal vector, a perpendicular unit vector for this sheet. The perpendicular unit vector for this sheet up to the point of interest is plus az bar. So in place of an bar, I can take az bar. Similarly, what is E2 P bar? It is nothing but the electric field intensity at the same point P due to the second sheet. So what is the ρs for the second sheet? It is minus sigma. Hence, it can be taken as minus sigma by 2 epsilon naught. What is the unit normal vector for this sheet? This is the unit normal vector for the sheet. It is minus az bar, because you need to draw a unit vector from the charged sheet to the point of interest. That is the reason why for this sheet it is in positive z direction, for this sheet it is in negative z direction. So you will get minus az bar. So what is the final answer? You will get 2 lambda by 2 epsilon naught az bar. So finally you get magnitude of EP. Magnitude of EP means the magnitude of the field intensity at any point P which is in between the two charged sheets of opposite polarity. So it is given by lambda by epsilon naught. So this is given as the first option in the question paper. So this is the correct answer, lambda by epsilon naught. In this way you can solve this question. Now we will do one more question. So the question is like this: a uniform electric field is directed along the positive x-axis and its magnitude is. A uniform electric field is directed along the, see, you have a uniform electric field which is directed along positive x-axis. I am assuming this direction as positive x for simplicity, and its magnitude, the magnitude is 60 Newton per Coulomb, because the electric field intensity unit is Newton per Coulomb. because electric field intensity is nothing but force per unit charge. Force unit is Newton and charge unit is Coulomb. So the electric field intensity unit is Newton per Coulomb, or the most commonly used unit is volt per meter. So the electric field intensity, which is directed uniformly in positive x direction, and it has the magnitude of 16 Newton per Coulomb given. What is the potential difference between 2 points at a distance? What is the potential difference between 2 points at a distance? X1 is equal to 5 centimeters and X2 is equal to 15 centimeters given. Okay. So we need to find the potential difference between the 2 points which are at different distances. One is at 5 centimeters and another one is at 15 centimeters given. How can you solve this? See, first we need to write the electric field intensity in terms of magnitude as well as direction. So electric field intensity is directed along positive x. So it is plus Ax bar and the magnitude is 60. So 60 Ax bar Newton per Coulomb or volt per meter is the electric field intensity. And what we need to find is the potential difference between x1 and x2. See, when you see the options, you need to find whether you need to know what is the initial point and what is the final point. As all options are positive, you need to find the potential difference of x1 with respect to x2, because x1 is at a distance of 5 centimeters. Is it right or not? X1 is at a distance of 5 centimeters and x2 is at a distance of 15 centimeters. So usually the point which is near to the origin or near to the field will have highest potential. Now how can I find the potential difference between x1 and x2? So V can be given by minus integral of E dot dl, right? So minus integral of x is from, I can take in reverse direction because to get the positive potential. So x is equal to 15 centimeters to 5 centimeters. E bar is 60 Ax bar dot dl bar is dx Ax bar. You have only in x direction. So Ax bar dot Ax bar is 160 dx. So 60 is constant for this integration. So minus 60 integration of dx is x within the limits of 5 centimeters minus 15 centimeters. Okay. So minus 60 into 5 minus 15 is minus 10. So we get 60 into 10, 600 centimeters means 10 power minus 2 volts. So 600 10 power minus 2 volts is 6 volts. So in this way you can find directly the potential difference between the 2 points in this way by using the relation. If you know this relation, you can find it easily. This is the option, this is the answer. So in the question it is given as the second option. So 6 volts is the answer for this question. Okay. And we'll see one more thing, one more question. So actually this key is released I think on 16th of March. The key has been released already. You can go through that key, but there are some mistakes in the key. There are some answers that are not given. Another question: 2 parallel conducting plates separated by 3 centimeters. Okay. So it is given that you have the question is like this: you have 2 parallel plates separated by 3 centimeters, and these 2 parallel plates are supplied with a potential difference of 72 kilovolts. Now, in between these 2 plates, a mica material is introduced. The thickness of this mica material is 1 centimeter. Now, what we need to find is the electric field intensity in the air medium. This is the air, because previously when when you have not introduced any dielectric material, you have 3 centimeters of air content in between the two plates. But as you have included mica material, so the thickness of mica material is 1 centimeter and the thickness of air is 2 centimeters now. Okay, so it looks like two capacitors that are connected in series. Two capacitors that are connected in series. This is capacitance of mica and this is for capacitance of air. So this combination looks like two capacitors that are connected in series across a voltage source of 72 kilovolts. Now what we need to find is the electric field intensity in air medium. If you how can you find the electric field intensity? If you know the potential and the distance or the thickness of air, you can find the electric field intensity. So you know that the thickness of air is already 2 centimeters because we introduced mica material of 1 centimeters in between the two plates. So you get D as 2 centimeters already. What we need to find is V. When you have two capacitors that are connected in series, in order to find the voltage across this, how can I find? So voltage across air dielectric medium, air capacitance, is VCA is equal to 72 kilovolt into, what is the capacitance? You need to multiply with opposite capacitors because the voltage division rule is different for capacitance when compared to inductors and resistors. I hope you know that. So 72 kV into Cm by Cm plus Ca. How can I find Cm? Cm is it is normal expression. It is epsilon A by D. The capacitance. What is epsilon? Epsilon naught into epsilon R A by D. So the relative permittivity of the mica is given as 4. So I can write epsilon naught into epsilon R is 4 into A. Area of cross section of mica as well as this air both are same, but the thickness is different. What is D? D is 1 centimeter because the mica material has the thickness of 1 centimeter. So what you will get 1 centimeter, if you send it to numerator, you will get 100. So 4 into 100, 400 epsilon naught A. This is Cm value. Similarly, how can you find Ca, air capacitance? It is also given as epsilon into A by D, where epsilon can be taken as epsilon naught into epsilon R into A by D. What is epsilon R? Epsilon R is 1. So we will get epsilon A by, what is D? The air thickness is 2 centimeters, so you will get 2 into 10 power minus 2. When you send it to numerator, you will get 100 by 2. 100 by 2 is 50. So it is 50 epsilon naught A. So the mica capacitance is 400 epsilon naught A. The air capacitance is 50 epsilon naught into A. How can you find VCA now? VCA is 72 kilovolt into Cm. What is Cm? 400 epsilon naught A divided with Cm plus Ca. Cm plus Ca is 400 plus 50, 450 epsilon naught into A. So epsilon naught A gets cancelled. I can cancel these 58s and 59s, 9 ones, 9 eights. So 8 into 8, 64 kilovolts. So the potential that is applied across the air capacitance is 64 kilovolts here, and the remaining 8. Out of 72, 64 is available here, and the remaining 8 is available at Cm. Now how can you find the electric field intensity? The potential difference applied to this capacitor and the distance. So it is 64 kilovolts divided with, what is the thickness of it? 2 centimeters. So the electric field intensity in kilovolt per centimeter is 32 kilovolt per centimeter for air. Whereas for mica, it is 8 kilovolt per 1 centimeter. So it is 8 kilovolt per centimeter. So this is the answer for the question. In this way, you can find the electric field intensity of a air medium in a parallel plate capacitor. Okay, so in this way you can find the electric field intensity. So the answer for this question is 32 kilovolt per centimeter. So with this, I want to end my discussion on the questions on electromagnetic fields. If we have some more time, we'll solve some more questions on the same subject. We'll complete all the questions. If we have some more time, in the next video, we'll solve the questions on the circuit analysis that were asked in the examination. Okay. So thank you very much for listening to this video. So if anyone want to know how many questions asked on different subjects, so APPSC has released the key of Polytechnic Lecturers examination. So they have specified, they have separated the questions from each subject easily. See, you can identify what are the questions from each subject easily because they gathered all the questions at a place for each and every subject. So how many questions from circuits, how many questions from control systems, how many questions from electromagnetic fields. You can observe all these things in the key. But in my view, for the subjects, electromagnetic field subject, some of the answers were wrong. Okay, so please go through that key. So thank you very much. If you really like this video, please share and subscribe to this channel. Thank you very much.